In this lesson, you'll learn to add and subtract matrices and multiply by a matrix scalar. How can matrices be used to calculate daily dietary needs? In her job as a hospital dietitian, Celeste designs weekly menus for her patients and tracks various nutrients for each daily diet. The following table shows the calories, protein, and fat in a patient's meals over a 3-day period. These data can be organized in 3 matrices representing breakfast, lunch, and dinner. The daily totals can be found by adding the 3 matrices. If A and B are 2 m by n matrices, then A plus B is an m by n matrix, in which each element is the sum of the corresponding elements of A and B. So to find the sum of matrix A and matrix B, they both have to have the same dimensions, which they do. So all I'm going to have to do is add 6 plus -3, 4 plus 1, -1 plus 0, and 0 plus 3. And I get 3, 5, -1, and 3, and that's all there is to that. Now, if they try to have me add something with different dimensions, I'm going to say, it can't be done. We're done. In order to add, they have to have the same dimensions or we can't do it. So to subtract, same thing, only I'm going to have 3 minus -2, 2 minus 1, -1 minus 0, and 0 minus -1. So 5, 1, -1, and 1. I draw my brackets at the end so I know where to put them, and we're done. So once you get comfortable with adding and subtracting matrices, this is one of the few things I am okay with you just writing down the answer. The table below shows the total number of households in the United States and the number of U.S. households that had a computer, PC, in given years. Use the matrices to find the number of U.S. households without a PC. Hey, notice we did not use the years when we made our matrices because the data isn't necessary. So all they asked us to do was take the total number of households and the number of households with a PC and find the difference. And then once they found the difference, sure, we can add a label. And there's our solution. Could you have done this without matrices? Yeah, probably, but it's a nice way of organizing the data. You can multiply any matrix by a constant called a scalar. This operation is called scalar multiplication. The product of a scalar k and an m by n matrix is an m by n matrix in which each element equals k times the corresponding elements of the original matrix. So to find 2 times matrix A, we're going to take each element in A and multiply it by 2. 2 times 2 is 4. 2 times 1 is 2. 2 times -1. 2 times 3. 2 times 0. And 2 times 5. And we're done. For any matrices A, B, and C with the same dimensions and any scalar C, the following properties are true. The community property of addition is true. It doesn't matter the order we add in. The associative property of addition is true. Again, it kind of doesn't matter the order we add in. The distributive property is true for scalars. The matrix 0, 0, 0 is called a zero matrix. It is the additive identity matrix for any 2 by 2 matrix. How is this similar to the additive identity for real numbers? Now things get more interesting when they ask us to find 4 times matrix A minus 3 times matrix B. So we want to take each element in matrix A times 4 and each element in matrix B times, I'm going to take it times -3, and then I can add. So I have 6, -3, 0, and 3. And then we add, 8 plus 6 is 14, 12 plus -3 is 9, -4 plus 0 is -4, and 0 plus 3 is 3. You could have also just distributed the 3 and then subtracted. Then 8 minus negative 6 is 14. 12 minus 3 is 9. Negative 4 minus 0 is negative 4. And 0 minus negative 3 is 3. Suit yourself. I'd probably go with this one, but we get the same answer either way. The order of operations for matrices is similar to that of real numbers. Perform scalar multiplication before matrix addition and subtraction. Matrices can be added or subtracted if they have the same dimensions. Add or subtract corresponding elements. To multiply a matrix by a scalar, multiply each element in the matrix by the scalar k.